You can find this question in 2012. 42nd question. Let's convert a VT graph to an ST graph. Very important topic. Look at this. What information can we get from a VT graph? From the area of a velocity time graph, we can get the displacement. From the gradient of a VT time graph, we can get what? The acceleration. By the y coordinate, we can see how velocity varies with time. Displacement with time. By the gradient of the ST time graph, we can get what? The velocity. Fine. Now let's see. What's happening? I label this as compartment 1, this as compartment 2, this as compartment 3, this is 4, this is 5. What's happening here? In compartment 1, what can you see? Yeah, the y coordinate is increasing. That means the velocity is increasing. We can see that the area is increasing. Generally, when you go, what happens? From the left to the right, yeah, area is increasing. Point number 1, in segment 1, area is increasing. But how does the area increase? Now we know the area under the VT graph gives you displacement. So whatever that happens to the area should happen to the displacement. I hope it's clear. Now the area is increasing. You can see that. But how does the area increase? How does the area increase? The area increases what? With interest. The area likes to increase. The area is increasing with what? Increasing interest. Can you see that the interest is increasing with time? So the area increases with what? Increasing interest. Whatever that happens to the area of the VT graph should happen to the displacement. Therefore, the displacement is increasing with what? Interest. What interest? Increasing interest. So what kind of a graph should you get for portion A, portion 1? This one, or this one? This constant interest, the interest is constant. This what? Decreasing interest. We now increasing the displacement. This what? Increasing interest. It likes to increase the displacement. Therefore, you should get a graph like this. But is this correct? Wrong. Why? We know that of a VT time graph, the gradient gives us acceleration. And from the y coordinate, we can see what? The velocity values. Now, can you see at this point, the velocity is 0? By an ST time graph, from the gradient of an ST time graph, we can see what the velocity is. Gradient of ST time graph is equal to what? The velocity. Therefore, we know here at this point at the origin, we can see velocity is 0. Therefore, the gradient should also be what? 0. Therefore, how should we start? It should start like this. We have to show that the velocity is 0. Therefore, it comes like this. Right. That should be a curve. I hope it's clear. Now, after that, look at this point. Now, look at portion 2. Is the area increasing? Question number 1. Is the area increasing? Area is increasing in portion number 2. If the area increases, displacement should be increasing. If the area increases, the displacement should be increasing. But how does the area increase? With constant interest. It just keeps on increasing in the same way. Therefore, displacement should also show that same ability. Therefore, what should happen to the displacement? Yeah, what should happen to the displacement? It should have that constant interest. Now here you can see some special feature. You know that the gradient of an ST time graph gives you what? The velocity. Can you see that the gradient is constant? The gradient here is constant. If the gradient is constant, now we know the ST graph, from the From the gradient you get velocity. If the gradient is constant, that means what? The velocity is constant. velocity is constant. I hope you can understand this. The gradient is constant, the velocity is constant. In portion 3, what can you see? Yeah, I'm going from left to the right. Still the area is increasing. The area increases. Look at the trapezium, the area increases. But how does the area increase? The amount by which the area increases with time is less now. Earlier it increased a lot, now little, even more little. Therefore, we can see that the area increases, but how does it increase? With reluctance. It doesn't like to increase its area. Same thing should happen to the displacement. Whatever that happens to the area of a VT graph should happen to the displacement. Therefore, we can say when the area increases with reluctancy, what should happen? The displacement should also increase with what? Reluctancy. How can you show reluctancy? This shows reluctancy. I'm going to be very careful. I'm going to come to what? A zero slope. That means a zero gradient. Again, why? I'm coming to zero velocity again. At this point, the gradient should show me what? The velocity. Gradient of an ST graph is the velocity. Therefore, at this point, I should get what? Zero velocity. I hope it's clear. Now, what's happening? Look at portion 4. Now, here what we found is what? The positive area. Here we found is what? The negative area. What's happening to the negative area? Negative area increases with interest. Can you see that? The negative area increases with interest. If the negative area increases with interest, if it's negative area, it should be negative displacement. If it's positive area, it should be what? Positive displacement. If the negative area increases with interest, the negative displacement should also increase with interest. That means what should happen to the positive displacement? The positive displacement is decreased soon with interest. It likes to decrease what? The positive displacement. Because the negative displacement is increasing quickly with interest, what can we say? The positive displacement should be decreased with interest. So what should happen? Quickly it tries to what? Decrease what? Decrease the positive displacement. It's a graph like this. Okay, right. Now because a graph like this shows what? Decreasing of the slope now. This means what? Increasing of the slope. So I should get what? I should get what? Yeah, I should get a negative slope that is increasing because the velocity is increasing. The gradient gives you what? The velocity. Negative gradient increases, therefore negative velocity should increase. Now look at compartment number 5. What's happening? Negative area increases, correct? But how does it increase? It increases with decreasing interest. It does not like to increase the negative area. Therefore, what should happen to the positive displacement? If the negative area increases with decreasing interest, doesn't like to increase the negative area, then what should happen to the negative displacement? Negative displacement increases with decreasing interest. Same thing happens to the displacement. What should happen to the positive displacement then? It is decreased not with interest. Just decrease it, no? Therefore, what should happen? It should come like that. It comes back to what? Zero velocity. Therefore, you should get what? Zero gradient again. Can you see that the overall positive area is greater than the overall negative area? Therefore, you should get what? An overall net positive displacement. Net positive displacement. Right, I hope you understood a lot from this.